Hey everyone, welcome to 360-degree Data Podcast, where we deep dive into real-world AI engineering. Today's topic, how to build production-grade LLM pipelines, something every company using AI absolutely needs to get it right. Most companies can build a proof-of-concept AI demo in a day. What they struggle with is turning that demo into a reliable, secure, cost-efficient production system. So in this episode, I will walk you through the 4 pillars of a production-ready LLM pipeline. Number 1, caching. Number 2, guardrails. Number 3, monitoring. And number 4, telemetry and evaluation. Let's break each one down. Caching, the number 1 cost saver most teams forget. Every LLM request costs money. If your system receives repeated questions or similar prompts, you should never call the model again. There are 2 major caching layers. Prompt response cache. It stores identical prompts and return cache responses instantly. Tools like LangChain Cache, Redis, SQLite for lightweight apps are very useful for this purpose. This alone cuts 30 to 60% of LLM cost. And secondly, embedding cache. If you use RAG, you must cache embeddings. Generating embeddings repeatedly is both expensive and unnecessary. Most vector databases like Pinecone or VV8, Milvus or Chroma, they handle this automatically. Without caching, your LLM pipeline will be slow and too expensive. Second, guardrails, making AI predictable and safe. Guardrails prevent your model from hallucinating, leaking sensitive info, or generating harmful content. There are 3 main types of guardrails we need to be aware of. First is input guardrails, checking queries before sending them to the model. Is the prompt safe? Is it within your domain? Is the user authenticated? These are very important. And libraries like Guardrails AI or Pedantic or Giscard or Presidio, these are helpful for input guardrails. And secondly, output guardrails, validating the model's output. Does it match a schema? Does it contain forbidden content? Does it meet business rules? For example, forcing JSON responses through structured output. These are very important. And thirdly, tooling guardrails. If your agent can call actions, for instance, SQL or API calls or file system access, you must enforce allowed tools, allowed parameters, rate limits, and sandboxing. It's important that agents without guardrails are a security incident waiting to happen. Third important point we need to understand is monitoring. The missing dashboard in most AI teams. See, traditional observability like CPU, memory, latency is not enough for AI solutions. LLM systems require AI-specific monitoring. For instance, model monitoring. We need to track token usage, response time, error rate, model drift, cost per request. And quality monitoring. You must detect hallucinations, off-topic responses, low-quality answers, toxic, unsafe outputs. And tools like weights and biases or Rise Phoenix, YLabs or Langsmith, these are very helpful for quality monitoring. And RAG monitoring. If you use retrieval, we need to monitor embedding quality, retrieval accuracy, chunk relevance, hallucination with ground truth mismatch. Most RAG failures are retrieval problems, not model problems. And fourthly, and finally, telemetry and evaluation. The feedback loop that makes AI better. Once your system is in production, you must measure how well it performs. This is where telemetry and evals come into picture. First, user telemetry. We need to track what users ask, which responses they like and dislike, drop-off points, query patterns, search versus generation performance. This tells us to analyze what to improve in our systems. And secondly, automated LLM evaluations. Regular benchmarks using synthetic test sets, golden data sets, task-specific scoring, hallucination detection, and answering consistency checks. These are very, very important. And frameworks like OpenAI evals or Langsmith evals or Deep Eval, these can help in automated LLM evaluations. And finally, human-in-the-loop review. It's very critical for enterprise systems. Humans need to validate correctness, safety, alignment with business rules. This closes the loop and improves your model over time. So putting it all together, the production LLM architecture looks like this. A real production pipeline will look like user, and then input guardrails, cache, and then router, and then RAG or any other tools, followed by LLM, and followed by output guardrails, and followed by telemetry, followed by monitoring dashboard, and finally continuous evaluation. If your LLM system doesn't include these components, it's not production ready. It's a prototype. To wrap up, let's recap the 4 pillars of a production-grade LLM pipelines. They are caching for speed and cost control, guardrails for safety and reliability, monitoring for operational stability, and finally telemetry and evaluation for continuous improvement. These are the engineering foundations behind every serious AI application, whether it's a chatbot, an agent, a rack system, or an autonomous workflow. If you nail these 4, your AI system becomes robust, scalable, and enterprise ready. Thanks for listening to 360-degree Data Podcast. If you enjoy this technical deep dive, hit follow and share with your engineering team. See you in the next episode.